Hi, my name is Sean. I'm a first-year power engineering student here at SAIT, working on my fourth class certificate. Today what we're doing is we're working with Turbine 2. So this is a medium low pressure turbine. What we have is we got the steam coming in from the medium pressure header here, comes through, obviously does the work through the turbine so we can get power out of the generator, and it eventually vents out of here in the low pressure header, where obviously it's going to be much lower pressure. If you come over to the control panel, you can actually see that we're pumping out 37 kilowatts right now. So, and then down here we also have the steam supply. So part of getting ourselves up to the power output is we don't necessarily want to just be maximum pressure, because there's a kind of like a power arc where you get up to a certain point in pressure where you're getting enough steam coming through to do the work. But if you go too high a pressure, your actual output comes down because you're not getting enough steam coming through the turbine. You just got high pressure, but no volume of steam. So that's kind of what we're learning today, is how to maximize the efficiency with the steam we've got coming in to getting the maximum output on the generator to go and power the buildings. One of the most important parts of turbines is that we have to have drain lines, because obviously with steam, if it turns into condensate, that can actually ruin all the internal components. So we have multiple drain lines here. We've got two that go right into the housing of the turbine, another one just on the other side there. And on the back side, you'll notice attached to our medium and low pressure headers, we've got a couple steam traps, we've got bypass lines, we've got the isolation valves. So obviously the isolation valves you can use if you needed to isolate it, work on the trap. And then on the other side here, it's a little hard to see with the steam, but we've got a couple more traps on the back there, isolation valves, stuff like that. So another part here is we've got the automatic trip. So if the turbine were to go too fast or were to overspeed, this component right here would automatically trigger. So this motor would push this piece out, and this whole component would trip up, and that will shut down the whole turbine itself. Yeah, the turbine's running right now.
Okay.
Obviously, maintaining the pressure is important. We don't want to overpressure the components, only rate it to a certain point. One of the other components we have on the low pressure header actually is we've got our pressure safety valve on the back here. So in the event that we start pushing too much pressure into the low pressure header, and any of the systems aren't prepared to compensate for it quickly, that'll be the blow-off valve that releases to relieve some of the pressure so we don't cause any damage to the lines or to any of the fitting.
Well, how do you manage the condensate?
So one of the ways we do it is right from the beginning. Once we get the boiler up and running, like this morning we were stone cold. There was no pressure in the header, no pressure in the boiler. So what we do is we open up all of the bypass valves for the steam traps. So we open those up, we open our non-return valve on the boiler, and we just let steam start to flow through all the systems. And what that does is it warms up all the pipes, warms up all the components. Once we've got steam coming out of there so that cold air isn't causing it to condense, we close those back up, and then we can just let the steam traps do their job from there. If we were to just let the steam traps do their work from the beginning, it's possible that they wouldn't be able to keep up with the amount of condensate coming through, because again, the steam's gonna hit the cold pipes, flash into condensate again. So that's what we do right from the beginning. And similar principle when we're starting up the turbine here, that's why we have the bypass valve. So as the components are heating up, we can just let all the condensate flow out into the drains while everything's getting nice and warm. And then once the shaft starts spinning and we've actually got movement, we can close those off, and the steam traps will do their job effectively, because we're not risking any cold pipes splashing everything back into condensate.